Welcome to the simulation part of our counters and clock dividers lab as a part of the FPGA Vhdl lecture series. In the last lab we wrote this particular code for creating a counter and a clock divider. Let us go ahead and test this code by writing a test bench. Writing the test bench for this particular code is by far the easiest of all the test benches that we have written. Let us go ahead and add a new source, call it a Vhdl test bench. Let us give it a name counter clock divider underscore TB for test bench. So here Xilinx creates a bunch of code for us, but we need to make certain editing to this code. The first one would be to remove this line number 62 from the code and to remove this block of line number 83 to 89. As the clock out is not really a clock, it's the output from our FPGA. Also, we need to reset our system for 100 nanoseconds. So we'll say reset is equal to 1, wait for 100 nanoseconds, and then we'll say reset is equal to 0. And that's it. Let us save this and simulate our test bench, or simulate our design with the help of our test bench. I double click on this simulate behavioral, which should ideally pop up a new window. Here I go and zoom out here we can see that our clock out is of the frequency 16 times less than that of the original clock input frequency. So here the clock frequency was or rather the clock timing was 10 nanoseconds. Here the clock timing is somewhere around 535 minus 375 nanoseconds, which is 16 times greater, or the difference is 160 nanoseconds over here. So the frequency here has been successfully divided by 16. Also, the decade counter that we just made is counting here from 0 moving on to 1 on the positive edge of clock out. If we go ahead and click this, that is run for 1 more microsecond, we can see that count is incrementing from 3, 4, 5, 6, 7, 8, 9, 10 and 0. So here it is counting from 0 to 10. So to make it count from 0 to 9, we'll go ahead and change this variable from 10 to 9 so that it will count for one less number. Synthesize the code. And then simulate behavioral again. This should ideally make our counter count from 0 to 9. So when the count reaches 9, our system will reset the count. Here I'll zoom out, and as we can see that after the count is reached 9, our counter is reset. That's it from the simulations lab.